you can see there is a audio, video, and then share screen, right?
Wait, I don't think I had that. Let me try again.
Oh, okay. Christian asked to share the screen. Okay, I passed slide control to you, so I'm not sure what else to do. If not, just send me those slides.
Yeah.
Easier to upload it here.
That was the Gmail address for you, right?
Say it again.
The Gmail address.
Yes. Yeah.
Yeah.
Hello.
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 While we're waiting, can we get somebody to take notes, please? If get any volunteer here.
Should be there. Sorry. Paul and I did some last minute discussion what to present and what to change, but we forgot to send you a copy.
Yeah, I see it. Again, I'm still looking for volunteer to take notes. If somebody can volunteer, that would be awesome. Okay, perfect. So, okay. Haven't seen any volunteer for taking notes. Anybody, please? Any taker? Come on, guys. No one? Okay, well, you go without taking notes, I guess. Let's get going. We have the recording anyway, so if somebody wants to see it, they can watch the recording later. Okay, welcome everyone. So let's get going. This is a reminder. Note well applies here, so note well is really important. If you're not familiar with this, make sure you are familiar with the note well, because it governs everything that we do at IETF. So please make sure you're familiar with this. Our schedule, we're almost done. So this would be our last interim meeting. And we have 3 topics to discuss today: that token list status list, the OAuth status attestation, and global token revocation. And reminder, IETF 120 is in Vancouver, is coming soon. So if you have any topics that you want to discuss, please let us know as soon as possible. Any questions, comments? Okay. Still have no volunteers for taking notes. Okay. I'm going to share. Let's start with Christian. You want to get us going here? Thanks, Arndt, for taking notes. Appreciate that.
Yeah, I think Paul is starting, so I'm after that.
Okay, Paul, go ahead.
Yes, thanks. Okay, so yes, I will start with OAuth. Token status list was formerly known as JOT status list. Working on this together with Christian and Tobias. Tobias can't be here. It's not a favorable time in New Zealand, this call, but we'll do it, the 2 of us. Yeah, we prepared some slides. The token status list was suggested April of last year and was then adopted quite quickly to the OAuth working group. So yeah, let's jump into it. Next slide, please. So yeah, very short overview of how this works. The wallet will send a presentation of a token to the verifier. So this is an example for the issuer holder verifier model, but could apply also to other things like access tokens. But in this example here, the wallet sends a presentation to the verifier. This contains what we call the reference token. Reference token contains a status claim, and in there we have an index and a URI. The URI points to the status list token, and the verifier in step 2 will send a request over get HTTPS to fetch the list. The issuer, which maintains the reference token, may update the statuses of the referenced tokens, and multiple reference tokens are then combined into one big status list, which is hosted by the status provider. The issuer can also be the status provider himself. He is responsible for hosting the status list tokens. So he will receive the get HTTPS with the URI, and he will, as a response, return the status list token. And then the verifier can look through this status list token and take the index, which is also in the referenced token status object, and then look at a specific index within this list. And then these bits, or this bit, will represent the status of the reference token. And if the issuer wants to update things, he can do update, and then there will just be a new status list token available at the status provider. And in that way, the verifier knows how the status changes. Important changes that we did, because we received the feedback that we may want other status mechanisms, is that previously we had the status claim, which directly included the URI and the index. We now have a CNF-like style, where we have a registry, and the name of the particular status mechanism is then used in the status object. In our case, we register the status _list claim, and then now this one contains the URI and index, which is particular or specific to the token status list. If you have other mechanism, then you could again use the status claim, and then have a different claim underneath that matches to other specifications. And we'll see that in the second or third presentation. So this was one of the recent changes that is quite important to today's topic. What else are we working on? There was a request that there should be a list, basically a list of status list token URIs. This is handy if you want to fetch upfront all the relevant status list tokens, for example, for a specific credential. So imagine you may want some offline or caching support for a police officer who's driving in the countryside and may not have access to the status list provider. So he may fetch all the relevant status list tokens for mobile driving licenses in the morning and cache these for one day. So therefore, we have this aggregation thing where he can find out where to find all status list tokens. This is one of the recent changes. And the second discussion is something that was also brought up from ISO MDL territory, is that people not only wanted, not only considering status list and the status list token, but they would also want is a more simpler mechanism that is more similar to a CRL. We gave this a lot of thought, and the request kind of came up again and again. But we decided that this is too much or overloading the status list token specification. So we opted not to include it in the status list specification, but drafted a very early separate draft that again also makes use of the generic status claim that we have, and could also be just a new entry for the upcoming registry. And this behaves quite similar to a CRL, where you only include specific identifiers, and then these identifiers have a status, but all other ones that are not mentioned have like a default status. Basically how our CRL works.
One use case, or like one requirement we have seen, is if people want to basically have a way to figure out when a status changed. There are certain use cases, domains, and so on that explicitly wanted the ability to see when the status change occurred, which is not very easily doable with current status list, and we do not think fits that model very well.
The exact time the status changed?
Yeah.
Sorry, just curious.
Yeah. So basically, the possibility to add metadata to a status. Right now, status list is optimized to only have current status. We have gotten feedback from several implementers that they have use cases where they want additional metadata, which, in my opinion, doesn't make a lot of sense with the current status list, which is more in line with classical CRL approach.
Christian, do you want to continue here?
Okay, so open points. Early on, we got feedback that people were interested in an unsigned option, so basically an endpoint to just return CBOR JSON directly. We are currently strongly considering removing this option. So if you're interested in this, please reach out. Right now, we've seen not too much uptake on this, and it makes this draft, the spec, quite a bit harder to read, in my opinion, or in our opinion.
Brian,
Yep.
Brian, you want to elaborate on your why?
I guess Carson kind of touched on it, but
why?
Yeah.
On what point exactly? Sorry, what was the question?
why remove the unsigned status list option?
So we reached out to some implementers, and most people so far told us that they would only be using the signed option, so some kind of token. And it made writing and reading the spec quite a bit harder. So if you have use cases and would be interested in explicitly the unsigned option, please tell us.
And in most people means all people.
Yeah.
We haven't heard anyone who's considering to implement the unsigned status list option. And if you have a feature in your draft that's not being implemented by anyone, it's probably a sign that it's not relevant. So that's why we're putting it up for discussion.
Giuseppe?
Ciao, Paul. Hey, boys. Well, it depends by the requirements of no repudiation. If a party have to demonstrate that something was not revoked in a specific time in the past, signature helps in this.
That was one of the reasons why we've seen quite a bit of, let's say, preferred using the signed option. Yeah.
I would say that this is related to the trust framework where the specification is going to be adopted. Therefore, it makes sense to me allow this in the technical specification, despite if it will be used or not in specific context.
So you would keep both options?
Yeah, as it was for JWT, we may have an unsigned JWT and signed JWT, and it makes sense to keep both of them, or otherwise you will be forced to separate this to another draft, the signed one, I say.
Okay, Christian, we only
Let's
have
discuss.
3 minutes per draft, so I think we should
Yep.
continue. If anyone else is thinking removing it would be a bad idea, then please reach out.
So to-dos, there was some discussion about the public key, basically key resolution parts for the status list. We need to detail out the validation rules. That is a big to-do that is still missing. We need the valid mloc example. I think that is soon-ish done. Yeah, there was a feature request from at least 2 people for, can we get this for a specific point in time? That is something that we are currently considering, not entirely sure right now. And then Paul, the comparison of status mechanisms. I think you can say a bit more about that one, right?
Yeah, so as there are multiple status mechanisms upcoming, and we have a lot from the X509 world, I think we want to try to compare those. I think that was also a request from IETF, that we get some information when to use what, and we're currently making a comparison with some Italian friends from Giuseppe, and then we will see where this fits in. I think, in my opinion, it should not go directly into status list, but maybe it makes sense if we have multiple status mechanisms to have an informational RFC, how these compare to each other. Yeah, and then I think we had some slides on comparing to the others. I'm not entirely sure if we want to go through these and now,
Yeah,
or
maybe briefly, just each one of those, one sentence on those, right?
Yeah, so the status assertion is apparently the new name. I would say it's very similar to OCSP stapling, or I think it was called validity credentials as well beforehand. We also considered that option in the beginning, but we thought we need something like status list as well. So we think we kind of need different mechanisms for different requirements, different use cases. That is also the reason why we chose to switch to this CNF style status claim. So it's basically a defined extension point for a different kind of mechanism. Next slide, please. So global token revocation, the way I understood it, is basically an endpoint that allows you to revoke specific tokens, for example, every access token or whatever from a specific user. The concrete concept of revocation or status mechanism is kind of out of scope for self-contained tokens. So this could be used basically to trigger the revocation via status list or something else. So it could be something basically in front of status list or like combined with it, from my understanding. So it's not an alternative.
Okay, awesome. Paul and Christian, thank you very much for this. Anybody has any questions, comments?
Do you have any feedback on the discussions regarding the more CRL-like approach, identifier list?
Hey guys, I can only say that it seems to me that we are going to live in a world where revocation leads to different use cases, and probably in our real world we will not be able to live with a single revocation check mechanisms, because there are some cases where airline party is allowed to monitor a status of a credential over time, even outside of the scope of a single user authentication. Another case that where it is not supported or allowed for privacy reasons. And this is something that I'm going to talk during my presentation about status assertion.
Okay.
Okay, Rifa.
Yeah,
please.
that's awesome. Thanks, Giuseppe. So this is good. Paul and Christian, thank you. I think we need probably a longer presentation discussion in Vancouver. So please be ready for that, and hopefully we'll have one of you present again in Vancouver. We'll give you more time for that. Okay, let me switch to Giuseppe's. Okay, let me hand you the control, Giuseppe. See if you can do it yourself.
Wow. Oh, it works.
There you go.
Yeah. This is my first time I present on this platform. Hello to everybody. I'm Giuseppe. I live in the south of Italy, therefore it looks that I'm pretty wet. Here we have 35 centigrades. But anyway, I'm very happy today to talk about a specification that actually is an individual draft that was born roughly 6 months ago. And as you may see from this slide, the title is changed. It was born as OAuth status attestation, and according to the feedback given by our community, it became OAuth status assertion. And another evidence that I'm not alone in writing this specification. We are me, Francesco Marino of the Italian National Printing Services, and Ori Stili, that has already presented this individual draft during the previous IETF meeting, I suppose in Brisbane. Well, what status assertion is technically a signed artifact. It could be of different formats, and at this stage we support JWT and CWT, and it demonstrates the validity of a digital credential, in particular the non-revocation status of a digital credential. It is issued by the same digital credential issuer of the digital credential where it refers to, and the holder, the wallet, obtains it automatically, and therefore should present the status assertion along together with the related credential to the relying party. Status assertion allowed to not renew a credential requiring LOA high, because at least in my church, we believe that credential issued with a LOA high should not be obtainable using a refresh token. And another is that a status assertion allow the relying party must not, definitely the relying party, since the relying party should not have any other interaction outside with the one with the wallet instance. Well, the status assertion allow the relying party, or otherwise allow the wallet instance to present the proof of no revocation of a digital credential. Therefore, the relying party is not forced to reach the credential issuer or any other status list provider. And the most important reason why this specification was born is that status assertion allows that the relying party checks the no revocation status, and at the same time does not allow a relying party to continuously check the status of that credential over time. And this is an example of a digital credential that supports the status assertion. And as mentioned by Paul and Christian, we use the same JSON object status, where along with, aside with the status list, we may have also status assertion, and this make us evident that a single digital credential may support both status list and status assertion. This is an example of a request and also a response. As evident, we use application JSON, and in a single HTTP request, we are able to request more than a single status assertion belonging to more digital credential. This means that if a credential issuer is able to issue or have already issued more than a single credential to a single holder, the holder with a single request is able to obtain all the status assertion it needs, and therefore the response is an HTTP 200 with content type application JSON, and an array with all the responses, where within the status assertion response array, we may have status assertion or status assertion error, respecting the index value, the position of each artifact in relation to the position of the request object in the HTTP request. Here, an example of status assertion request object where proof of possession mechanism is required to demonstrate the possession and the control of the digital credential, where an older request a related assertion, and this is a status assertion object. Or else, I would say that status assertion is therefore signed by the credential issuer and must be presented to a relying party. Well, I can tell you that in the current implementation, the holder present the status assertion within the VP token using, for example, OpenID for verifiable presentations. Next step, I would work more on the different use.
Giuseppe, there's a question from Christina. Do you want to take a look at this? Christina, do you want to talk about that question?
Yes, so Giuseppe, this is basically the model where it's not the verifier, but the wallet obtaining the status list and sending it to the verifier, right?
Ciao, Cristina. Yes.
So I do have concerns with that model. We spent a lot of time discussing it, one of the large-scale pilots in Europe, and where people were trying to entertain that idea. And basically, I think one of the big conclusions was, if the verifier is trusting the wallet to do all the status management, like, why do you need issuer signature and all that in the first place, right? So, and also from a, I'm not sure how much privacy preservation it adds either, because the issuer doesn't know who's calling wallet with the verifier anyway, right? I think John was making that point earlier. But I think my larger question is, enabling this model where wallet is fetching status list on behalf of the verifier, what implication does it have on the trust between verifier and the wallet? And does it actually make sense from that perspective?
Sorry, Christina, I missed the question, but this obviously caused by my language level. You mixed a lot of things together. Are you asking about the value of wallet of the status assertion in comparison with status list, or about the burden that it's moved to the relying party in doing verification, or what? Can you replace the single question, please?
I'm concerned that wallet fetching the status list on behalf of the verifier does not really make sense from the perspective of the trust between verifier and the wallet. It's not a question, it's a big concern. I'm not sure we should enable it.
Well, this is our opportunity to have a good conversation. I can bring the evidence that the holder must be informed when a credential in possession of it is revoked. Therefore, obtaining the status assertion about the credential it holds is something that meet the requirements. And also, well, to inform the user at least. And therefore, this status assertion can be provided to relying party and verifier also in offline use cases. The relying party doesn't need to reach any other third party. So this is very efficient because in a single HTTP request, the holder provides all about the status, the digital credential and the status about themselves. The point is, working with legal teams, we are facing a big issue about are we sure that we may allow a relying party to continuously monitor status of a credential even outside the user authentication, me authenticating to relying party A yesterday. Relying party A, once have the index and the URL of the status list, is able to monitor the status of this credential over time. There are use cases where the relying party should or must doing this. An example is when a citizen requests and obtains social benefits or stuff like that. Other use cases that we are not enabled to do this. I'm not in favor of status assertion against status list. As Christian mentioned, my proposal was to include this approach because I'm driven by the requirements. First of all, the legal requirements. Probably the question we are working on is, are we sure that only 2 revocation check mechanisms are enough? Do we have mapped all the use cases that may raise the requirement to have another additional status check mechanism? And probably I didn't answer to your question, Christina.
Christina, do you have a follow-up? Do you want some clarification from Giuseppe?
I kind of do, but there was a lot of questions in the chat, so
yeah,
I don't know.
I see lots of comments in the chat. So people, anybody wants to kind of talk about this here instead of a chat there? Yeah, Paul,
yeah.
Go ahead.
Yeah, just to be sure about the discussion in the chat. So the difference to OCSP stabling is that this endpoint provided by the issuer is kind of protected so that the verifier cannot access it correctly. It's protected in a way that the wallet needs to do a signing operation to the request object.
Yeah, I just read a question from Oliver. Yes, it is correct. The wallet must prove to be in possession of a digital credential, so there are sort of protection based on the proof of possession of the credential.
I think that's also a little bit my concern because as it's designed right now, this means that the reference token, as I would call it in our spec, so the token that the status is about needs to have a CNF claim so that you can, because you need this key in the reference token to authenticate towards the issuer's status endpoint. What I would propose is that you would decouple this more from the referenced token, and I think you should more of provide keys within the issuance, because I think for us it would be interesting to allow reference token that don't have a CNF claim.
Anyway, I read Brian Campbell comment about the use of the months, and Rifat, probably we are going to define a new term, months. It's something different than knowns, but we may need another meeting. And Paul, yeah, actually we have stuck using confirmation method based on cryptographic proof. Did I miss something?
I would say my point is I would not base this proof on a key in the reference token, but on a key that is provided alongside during issuance. Otherwise, you can only make status assertions about tokens that have an embedded public key. If you, for example, take access tokens, an access token can be opaque and does not contain a public key that can be checked.
I fully agree with you. There may be several confirmation methods. In the last changes in the individual draft, we have played more about this requirement to get this generalized. At the same time, we have provided some concrete and practical example. using a cryptographic proof of possession. But during a presentation, we know there may be different proof of possession mechanisms, different than cryptographic. Regarding the which public key to use, I'm not also a great fan of the linked keys, or at least for today. I'm trying to keep the specification simple without playing with key derivation mechanisms and stuff like that. The individual draft is pretty, I would say, it's pretty fresh, and well, probably we should continue. At this stage, it is my interest to consolidate the requirement to have even another revocation verification mechanism.
Okay, Oliver.
Hey, hello. Yeah, so would it make sense to protect the status endpoint using the same depop key, assuming you are issuing the credential using OpenID for VCI through the credentials endpoint? Then you might solve some of the problems, or might address also Paul's comment.
Yeah, we know that there was a lot of discussion about wallet trust evidence, an array of attested reliable cryptographic key in possession of a single holder, and therefore there may be several opportunities in the future to extend how this endpoint can be protected, even with proof of possession demonstrated with key different from the one used in the digital credential. Please, open issue. Nothing will be overlooked,
Okay. Christian.
Yeah, one question regarding, let's say, scope. One of the discussions we always had when talking about this was, if you can request a new credential, why would you use some kind of status assertion? Because you could just do short-lived credentials, and that would be basically your freshness, right? So scope would be that this is used when you have LOR high, where it's not easy to get a new credential. Is that correct? And for the use cases where it is reasonable to just get a new credential, you would just do basically very short-lived credentials and use that instead?
Yeah. Let's talk about the story of the user that obtains a digital credential with LOA high and using the electronic identification card with NFC, proximity, PIN, and biometry. Well, all the stuff required for LOA high. A short-lived credential could be something less than 24 hours. And with service design that works in the field of user experience, we try to avoid this, because we do not want to force citizens to, the burden of LOA high for identification, authentication, and credential issuance. This is something that can be achieved because there may be strategies that say, no, we want to use refresh tokens, we want to use, but at least in Italy, there are several concerns about the use of refresh tokens, because there's something that went out from the control of the user, because we know that the refresh token is in control of the client, and a wallet instance at the end, what would be the value of the refresh token? User it automatically and obtain another digital credential. And we don't think that this matches the LOA high we want, and neither the user control that we want for the wallet ecosystem. But I'm not excluding other strategies based on short-lived credential. Something different.
Okay, Paul.
Yeah, I think the question from Christian is the most important one. If there are good reasons why this is better than short-lived credentials, I think then it's definitely worth to adopt this. it then has quite different trade-offs compared to status list. Just has different privacy trade-offs. It's probably, or most likely, definitely worse in scalability, but it might be more privacy preserving, depending on which use case you have. But I think the most important consideration is how does it compare to short-lived credentials?
Okay, thanks, Paul. Giuseppe, do you want to wrap it up with this last slide here?
I believe that we had a very good conversation.
Okay.
Thank you, guys.
Awesome. Thank you, Giuseppe. Hopefully we continue that discussion in Vancouver. Okay. Aaron, you have the floor and the control.
Great. Oh, yes, I do. Thank you. Okay. I'm going to give a quick background on the problem that this draft is solving, and then I have a couple of notes on how it relates to the others, at least in how I see it. So this is your typical OAuth flow of a client getting its tokens from an authorization server. I put these terms at the bottom, app and app backend, as more colloquial terms that you would find people using in discussions when they're talking about building things. So this is just your regular OAuth flow. What this draft does is adds a new endpoint to the authorization server, which an external tool or other or identity provider can use to tell that authorization server to revoke the tokens it has issued to a client application. So the idea being, in some cases, like in the identity provider use case, this would be if this client has done a federated login to an external identity provider, and that identity provider wants to tell eventually revoke the tokens from the client downstream. This is built on it uses the subject identifiers for security event tokens as the identifier in the revocation payload. This endpoint does require authentication, but that particular method of authentication is left out of scope, and that matches the token introspection, how token introspection handles authentication as well. In our current implementation, the authentication we're using is actually a very similar to the OpenID private key JOT client authentication. So it's a JOT sent in the it's sent in a bearer header rather than in the client assertion post body parameter, but the JOT is structured very similar to what you would find in OpenID's private key JOT method, which is actually RFC 7523. The expectation of this endpoint is that any refresh tokens issued are revoked. If it's possible to revoke access tokens, those should be revoked. I say if it's possible because some people have implemented access tokens in a way that are not revocable. And importantly, that authorization server must re-authenticate the user before issuing any new access tokens. This is what it looks like in a post request. So the actual endpoint is not defined, of course. That's just an example path. There's the JOT authentication in the authorization header. There's the user, in this case, is identified by an email address. There's a couple, because this is the subject identifiers format, there's a couple different options you can use to identify users, including an opaque ID or issuer subject. So, however, whichever way makes the most sense for the downstream server you're talking to is what you should use. The response is just an HTTP status code saying it worked or didn't work. There's no need to communicate anything really further than that. So if you return 204, that's an acknowledgement that the authorization server is processing the revocation. It is not. It doesn't have to be revoked synchronously. It can absolutely be done asynchronously. So that's why it's a 204 no content, and it's not meant to like acknowledge anything else beyond that. And then otherwise just standard error codes if something's wrong with the request. In doing this, I did a survey of other existing token revocation drafts in the various communities. And a quick summary of that: the RFC 7009 token revocation is it is a client-initiated call, and the input to that call is the token itself, which doesn't work for this case because the input in this case is about usually a user identifier. Front channel logout is a similar problem where it's client initiated, so it doesn't really work, and it also doesn't work because it's in the front channel. Back channel logout from OpenID Connect is the closest to this. However, the language in that mostly talks about terminating sessions, and it actually has a sentence which is a particular problem, which is that refresh tokens with offline access should not be revoked. And in our case, we explicitly want refresh tokens of all kinds to be revoked. There's some overlap with the OpenID shared signals framework, although the big difference there is that it is, as in the name, a signal. It's a signal about something that happened in one system. So the closest you could get to map to this use case would be the identity provider sharing a signal saying that a user has gotten logged out of that identity provider, but it is not. It is explicitly not a command in the shared signals framework, and the receiver is expected to do whatever the receiver wants with the information it learns from these signals, which may or may not be taking action. And again, in our case, we want it to be a very clear command that the authorization server, it's a very clear contract that the authorization server does revoke those tokens. It's also a lot more infrastructure to set up to receive those. So that's the short summary. I think as mentioned in the first presentation, I compared this to the other ones we talked about today. I see this as like an input into this, like a thing that could cause any of these. This would cause a token to be revoked, and then how the revocation happens would be determined, based on however you're implementing token revocation. So, if you're using status assertions, then the authorization server would no longer issue. The expectation would be that the authorization server would not issue any further assertions that the token is valid when asked. And in the token status list, it would be that the authorization server would flip that bit in the status list, and that would cause the resource server to reject any requests with those tokens in the future. So basically, this would be an input to a system that uses either of these. The end.
Thanks, Aaron. That was quick, short, sweet. Okay, questions, comments, thoughts? Hannes.
Hi everyone. Sorry for being late. One question for me is, and we see, at least with the verifiable credentials work, a tendency to make tokens rather long-lived, and thereby we run into the issue that we suddenly need to have all sorts of different revocation mechanisms. And the question is, to me, is out of all of those, how many do we need? Because I see there's like I see a relationship to what has happened in the BKIX world, where all sorts of different mechanisms have been developed, and then like still people are unhappy because all of them have different pros and cons, and in the end it feels like a little bit of mess. And I'm wondering whether we can learn something from that environment, because they have gone through a little bit of pain already. I don't know. Maybe it's just me that has that thought, and maybe it didn't occur to anyone else. But
So this is a generic thought, Hannes, not specifically on this document, right?
That's completely correct. Yeah.
Okay.
I think it's
Okay.
a more general question.
Fair enough. So maybe we can get to that a little bit later. I just wanted to see if people have thoughts on this specific presentation. I see Oliver in the queue. Go ahead, Oliver.
Yeah, thank you. I think it's also a more general thought, but this presentation just triggered that thought. So you're saying this is a revocation endpoint. So in the status list draft, we currently define, or it's currently defined that that I think 3 different status bits or types: valid, invalid, suspended, and I don't know if there are similar status types in the status assertion draft that Giuseppe just presented. Do you think would it be needed to define status bits types across different status methods? Because otherwise you wouldn't really know what hitting the revocation endpoint will do with the respective token. So would it then be set to suspended or invalid? So I think there's definitely some interface discussion there.
Aaron, if you're speaking, we can't hear you. Oliver, you're back. Sorry.
Hello?
Yeah.
Can you hear me?
Yes, we can.
Oh, okay, so I was just wondering whether we should.
Oh, I think we lost Aaron. What is it?
Oh, okay.
Aaron, can you hear us?
I can hear you. I wasn't sure if that was a question for me.
Okay. Yeah, sorry.
Yeah, it was a question actually. So I think the concrete question for Aaron was, so if you revoke a token, would then how does the status list provider know in case of the status list specification what to do with the token? Would it set the token to suspended or invalid? Because currently the status list defines 3 different status types, and I guess
Sure.
for status assertion it might be even different. And then the follow-up question would be: do we need to standardize at least a revocation or revoked status type?
So I think Brian has said what I want to say, which is this: the intent of my draft has 0 to do with VCs. It is about OAuth in the traditional OAuth sense of apps getting tokens from an authorization server and needing to revoke those tokens. So I do think it's confusing grouping it with these other 2 presentations that are explicitly about VCs and wallets. So that probably didn't help the discussion here. I'm trying to go back to the OAuth world. So if I put in that last slide how it relates, because that was the homework we were given. But if you want to use a status list as a mechanism to keep track of OAuth access tokens, that's fine. You can do that. I think that there's some interesting uses of that, even though that's not the intent of the draft. And in that case, yeah, we probably need to make it very clear which of the flags to use. But that's, yeah.
Okay. Paul?
Yeah, I mostly wanted to refer to Oliver's comment. I think it would be valuable if the status types could be reused across these status mechanism drafts. Also, I thought it could be beneficial, like if the terminology between those 2 drafts is somehow aligned as good as possible, so that if readers want to compare different status mechanisms, it's easier to compare if the same terminology is used.
Okay, thanks, Paul. Peter.
Hey, Aaron, thanks for presenting this. I was curious, right, how does the authorization server then end up communicating back to things like the resource providers or the resource servers? Is that something that still needs to be done via SSE or CAPE or something like that?
Yeah, it's a good question. In the OAuth model, that link is traditionally out of scope. So if you look at all the definitions of how resource servers validate access tokens, those are that's out of scope of OAuth. And then we do have now one draft, which is the JOT access token draft that talks about how a resource server can validate an access token in that particular format. So that is to say, in some cases, the authorization server and resource servers are the same server. And in that case, there is no need for any complicated mechanism or any spec to define that behavior, because they're just the same server and it's all internal logic. If the authorization server and resource server are separate servers, then they're going to have to coordinate somehow. And that's where we need to start. We basically need the opposite of the JOT access token spec, which is how the authorization server and resource server can coordinate on revoking JOT access tokens. Other than that, it's just all internal implementation anyway. So how the main point is, how is the resource server validating the access token in the first place? Because the answer might be it's asking the authorization server every time using token introspection, in which case now you don't need to do any more work. Or the answer is you're using JOT access tokens and now you need to keep track of token statuses somewhere, which is where there is some overlap with, for example, the status list draft.
Okay.
And yes, Arndt in chat is reminding me that this is why revoking refresh tokens is a must and access tokens is a may, because revoking refresh tokens is something the authorization server can do on its own, which will prevent further access tokens from being issued. And revoking access tokens is a may because it's not always feasible depending on how you deployed it.
Okay.
Yeah, thanks, Aaron.
Thanks, Peter. Just wanna quickly, we have 2 minutes, 2.5 minutes here. Go back to Hannes's question about multiple revocation methods. Do we need all of those? And did we learn anything from the PKI experience? Anybody has any thoughts about this? Peter.
I don't think we did.
So Christian is in the queue. Christina, do you want to join the queue, please?
Yes.
Okay, Christian.
So my current take on revocation is, as long as we don't have scalable secure cryptographic accumulators, we basically need more than one model. There is basically no one system that fits everything, in my opinion, right now.
Okay, thanks, Christian. Christina.
Yeah, I don't think we're seeing any convergence towards a single model, and at least in the wallet space, right? Not talking about Aaron's draft / pure OAuth space. I don't think we have clear metrics who's using what when either. It's more like each implementation is choosing whatever seems to fit their requirements. And when that happens, from my experience in the wallet space, it's very hard to drive conversions. So yeah, I'm partially embracing myself for a world where there will be multiple invocation mechanisms and everyone will have to implement everything. Yeah.
Okay. Thanks, Christina. Anybody else before we wrap up here? Hannes, do you want to talk about this last comment here?
Yeah, which I made a typo in there anyway. Yeah, I was wondering whether it's out of all the mechanisms, and I've seen more being developed outside the IETF, on whether whether developers are actually aware of the criteria for deciding for one or the other mechanism. Whether that's such an easy decision, sort of like almost like a decision tree. Like if you have that deployment, go for this mechanism. Otherwise, go for this, and if there's yet another criteria, do this. I think that would be quite useful to avoid confusion. I can already see in a couple of years from now, people complaining about this topic.
Yeah. Okay. Thanks, Hannes. Good comment. So, yeah, clearly there is a need for more discussion about this. So hopefully we'll continue this discussion in Vancouver. Thank you all for all presenters or attendees, and let's continue this in Vancouver. Thank you.
Thank you.
Bye.
Bye-bye.
Bye.
Bye.